We're going to be demonstrating web growth here, but what I want you to know is that we're demonstrating a growing web from the very beginning in its first few increments of growth. So it's going to look very crude. And in an actual universe the size of ours, there would be billions of these cycles, millions of billions actually. And so we're showing you the first few. Just keep in mind that this is what we're seeing. But by doing so, we'll be able to demonstrate some of the very important properties of this kind of growth. And later we'll jump to the larger case where it's a mature universe. So this one is just, these demonstrations are of just the beginning of growth. So as we look at image 55, keep in mind that we're going through some heavy-duty stuff here, just previewing it. This isn't teaching it, but it gives you an idea of what this online course that I plan to teach will cover in more detail with some supplement material. But here you see, we're really going to be talking about the insight about light propagating from one location to another, because that's an extremely essential part of physics that's mysterious. So in this kind of expansion, it resolves a really tough issue, is that how does light travel on the surface, and how does that relate to the rate of expansion? I mentioned Marco Pereira again, because he has work on this, and I've done work on this, and I ran into the same confusion that he shows in there. This is a confusing issue. Well, if you look on the right, this kind of expansion is illustrated by simply it's showing 3 strings there, and as the radius, what you do is just lift 2 of the strings and make them follow a circular arc, and that can get bigger and bigger. What you're looking at there is a 1 radian angle on each side. So you can just continually grow a circle bigger and bigger and bigger in this manner. And this is the basic nature of web growth in this work. So we're going to see a demonstration of that, a little movie that shows it. And in that movie, we've put 2 little pieces of tape on the string, and you'll see that those little pieces of tape seem to propagate out as the circle expands. They do propagate out as the circle expands. You'll see that in the next little clip. This little clip will show the simplest kind of primal expansion. You see the starting point there where part of the substance, it goes all the way to the center, and another part is tangentially out in a circular sort of shape. We're going to run this now and let it continue. Now I'm just going to let this thing run up to the point you see those black tape marks on there. At some point they're going to separate and go in different directions, and we're going to stop it right before that. Now with that stopped, I'll point out that those marks can represent tokens of light. It's not exactly light traveling, but it defines the time that light travels. So you'll see those now spread out and travel out at the same speed of expansion. So every increment of expansion, the marks go out the same amount in the tangential directions. So the video clip that you just saw, where you had that's 3 strings really, and 2 of them just expanding as a circle, that was a breakthrough idea. It took years for suddenly that to come through, because when you think from the contemporary point of view, vector space point of view, if you think about light propagation from that conventional view, you just get nowhere. You go in a circle. And so what I wanted to do is now we're going to go into a different mode where now there's multiple of those strings, because that one concept of a string expanding into a circle can be, you can do that with multiple circles at the same time, and then it starts to look like a web, and you start thinking about, yeah, this is really a web. So we're going to go next into a more complicated web expansion that just involves more strings organized in a simple way. The image in image 60060 shows a mechanism that we use to demonstrate something more like web growth. And then the top, over in the far left, you see we've just got some strings, actually 4 pairs of strings, 5 pairs of strings coming down the middle of a channel, and I've used 2 combs, one on each side of the channel, that allow me to, position those strings in different places. So that mechanism is shown up at the top. We're going to illustrate web growth with that. Now the part below is that's a real web, and it just kind of shows you that this is just one portion like of a real web. I took that picture, really, that was near my chainsaw, and that spider the picture's so clear because the whole web was sprayed with sawdust. So we're talking really about a web like that, and this illustrates that kind of growth using the same mechanism we did with just the simple strings earlier. So let's watch this expanding web grow. I will say one thing, that we're using just straight tangential segments here because we're just making this simple. But as we'll see later, that can be different configurations. It doesn't have to be that simple straight line thing. This video is going to be a demonstration of expansion, web expansion. You see the device I've made here. It's got string going down the middle and 2 combs on the side to give us a way to show the web expanding. And here it is focused on with nothing yet happening. Now you see the first web started to appear there. So now we're just going to run this thing one step at a time, and you can see how the web is expanding, moving up, expanding out until it, whoops, photobombed. It gets to the top. So there we have the fully expanded web in this demonstration. And the next thing we want to talk about is this expansion triangle, which is shown right here in this picture. We'll repeat this picture in a static video and talk about it in the next little segment. So now we're going to watch it again, except this time I've got, I'm going to have a little rectangle that shows the body of the little sphere land atom. And remember, the body is an inner body. And so you'll see it expand and the tangential part of the web come out from the top of it. There you see the rectangle beginning. The primal extent is the number of notches up that comb there are. So it starts out primal extent 4. And now we're just going to watch it run. What's very important but not obvious is that half of the material stays inside that body of the atom and half of it goes out as tangential web elements.